Okay, how's it going there, Algebra 2 C folk? Hope you're doing well. Um, this video is the continuation of Lesson 7.3 Part 1, which was just simplifying a rational expression. This time I'm going to work through 3 examples. I have 2 up here, and then I'll pause the video and erase this and put a third one up there and just to get you the idea. But if you did and followed the first video, following this is not going to be that different. It requires a lot of the same work. So, sorry, I'm just going to adjust this camera a tiny bit. Okay, so here we go. Over here we have an example, and it is a fraction times another fraction. So, very similar to yesterday, you are going to just factor every single thing that you can first. And so that's what I'm going to do. Now the problem is I got 2 numerators, 2 denominators. I'm going to factor whatever I can, and I'll tell you where we go from there. So the first numerator right here has a greatest common factor. It's always the first thing you look for, of negative 3x. So if I factor out the negative 3x, that leaves me x there. Plus 1. Excuse me. That's minus 1. So there's that. Kind of think about if you think that times that would be negative 3x squared, and that times that, see, negative times negative would be plus. I almost messed up the sign there. Over. Now the denominator here is a trinomial. No greatest common factor, just your typical trinomial. That would be x and x for the x squared. Now I got to concentrate on the multiplying to negative 5 thing. It'll be negative 1 and positive 5. You check that distributive property back out, it will give you plus 4x in the middle, so that all works out. Okay, keeping the time sign here. This numerator is also a typical trinomial with no greatest common factor. So just write into 2 parentheses here, people, x and x. That's negative 20. What comes to mind with 20 is 4 times 5. And when I see this 1x in the middle, we're going to use minus 4 plus 5. And if you do check this multiplication out, it will be x squared. And the 5x minus 4x will make 1x, and the negative 4 and 5 make a minus 20. So it does work out. This 3x, it's a single term. There's no plus or minus signs, so there's no such thing as a GCF, or it stays 3x. So here's where we pick up from yesterday. Like all the factoring that I just did right there, we did that in the first video. Now, you have to recall when you multiply 2 fractions together, it's probably the nicest thing. Adding's a pain because you need a common denominator. Subtracting's a pain for the same reason. Multiplying is top multiply top, bottom multiply bottom. So what I'm allowed to do is just connect this like it was just one big ugly fraction. And remember yesterday, I concentrated next on reducing what I could. You have to concentrate on where are the multiplication signs, because where things are separated by multiplication is where I'm allowed to reduce. So there's a lot more here than you might believe. For example, and I'm going to highlight those all in red here. So there's a times sign here, 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 and here. And in the denominator, 1 here, 1 between these 2, and 1 between that. So anything, as long as it's surrounded by time sign. So in other words, I can't just reduce this x. The x minus 1 is a package deal. The x plus 5 is a package deal. The x minus 4, package. Now, some things I can reduce. First of all, 3 and 3 reduced. Now be careful, that negative sign's still there. This x and this x, because they're surrounded by times. The group of x minus 1, this group x minus 1, and this group of x plus 5, and that group of x plus 5. And I know that's getting kind of messy, so I'll kind of write what I think the answer is going to be, and if I notice I need to reduce something else, I will. If not, circle it, done. Left in the numerator is a negative, and then x minus 4, the group. And I need to keep the parentheses around it because the negative's out front. And then the denominator, look at that, the entire denominator, every single thing reduced, which just means that's the answer. All that reduced out, x minus 4 with the negative sign is the only thing left up top, everything else reduced out. So there's that. It's kind of like mixing 2 of yesterday's problems into 1, is what it is. Because you have 2 fractions to deal with, and that's just what you're doing, and then you reduce like yesterday. Okay? Here's another one over here. Similar in some ways, different in some ways. So here we go. First of all, this numerator, so we're just going to factor everything we can. This numerator has a greatest common factor of 2x. So if I factor that out, that leaves me an x minus 5. Just kind of check that out. 2x times x is 2x squared. 2x times minus 5 is negative 10x. We're good? Okay. Folks, this denominator is just a binomial. No greatest common factor, but it's a subtraction, perfect squares. We talked about that in the first video too. Subtraction of perfect squares. Difference of perfect squares. That's x, that's 5, 5. So we do x plus 5, x minus 5. Time sign. Now, the thing that's kind of nice about this example, x plus 3 doesn't factor at all. It doesn't have a greatest common factor. It's a plus sign, so it can't be difference of squares because that's got to be subtraction. So x plus 3 stays. And 2x squared also stays. That's not a factorable thing. It's got to at least be a binomial or a trinomial or something to factor. If it's a single term with no plus or minus signs, there's no factoring. So everything's factored to the best of our ability. Here we go. We can now, because it's multiplication, consider it's just one big fraction. And you must think of this as a group now, since it's being partnered with this numerator. And now we'll go into the reducing game. Anything numerator, denominator that's separated by multiplication. Here's the multiplications. 1 here, here, and here. Denominator here, here, and here. It's going to be a little bit interesting now. First of all, the 2's, 2, and this 2 are out. Now we got to be super careful. This is an x and this is an x squared, which means 1x will take out, I'll just cross out this square, only takes out one of the x's. Think of x squared as x times x. 1x takes out one of these x's, leaving me 1. Next, we got a matching group of x minus 5's right here. And again, now it doesn't look like I have anything else, so let me just write it like I'm going to write the final answer here. The numerator has x plus 3 only. I can have parentheses around it or not. There's nothing in front of it. That's the only thing there. And the bottom has x plus 5 and an x. I would normally write that like that. Now, for anybody thinking, can't you reduce that anywhere? You know, this x is what I would call in class eligible to reduce because it's got a time sign right here. But that x is not eligible. It's attached to a plus sign. No reducing. So that's it. So there's the final answer for that. Now, going to pause the video for just a second so I can erase. Remember, you have the luxury of pausing this video, looking at anything you need to closer up, but I'm going to pause, erase, and put the 7th and final example. Remember yesterday we did whenever you watched the other video, we did 1 through 4, so this is 5, 6, and 7. Let me pause a second. All right, here we go. So here's example 7. Got that all up there for you, so you can pause it anytime and write down whatever you need. So here we go, continuing. We're going to take these two, this multiplied to this, factor everything we can. Now, you can look at this one in advance. We just got a bunch of trinomials. They all need to be factored. I can look at all 4 trinomials that are sitting here quickly. No greatest common factors in any of them, so just get right down to business. So this top one, that's x for x squared. Now when I think of 12, I think of 3 times 4. And everything in this one is positive. Now if I check that out, it's 4x, 3x for 7x. And the 3 times 4 is 12, so that factors out nicely. We saw this one, or at least something super similar to this one in the previous example, or example 5, I think. So, break it up. X and x. Now, that's a negative 20, and again, the first thing that comes to mind is 4 times 5. Consider that's negative there, so I'm going to do plus 4 minus 5. If you check that multiplication, it will simplify to x squared minus x minus 20. Time sign. Factoring this, x and x. We saw something similar to this one as well. Now, multiplying to negative 5, there's only some combination of 5 times 1. It's going to be minus 5 plus 1. That will give you the proper, when multiplied, x squared minus 4x minus 5. And then the last one down here, that's also x times x. And multiplying to negative 21. Now when I hear 21, I think we think 7 and 3 right off the bat. This will be minus 7 plus 3. And if you multiply that all out, you will get, because see, this will give you 3x, this will give you minus 7. 3 minus 7 is the negative 4. It all works out. So now that I have everything factored, remember, times is just, everything is top, top, bottom, bottom matched up. We just draw the line across. Concentrate on where your multiplications are, because they are your separation for where you can reduce. So times here, times here, times here, times here, times here, times the here. So the difference in this example, there's none of these little single things like a 2 and a 2. There's no GCF. Everything's just groups. They travel as groups. So if we're looking, I see this x plus 3 can reduce with this x plus 3. See, and it doesn't matter where it is in the problem as long as one of them's in the numerator, one's in the denominator. You can't reduce 2 things in the numerator. It's got to be one of each. X plus 4, x plus 4. X minus 5, x minus 5. And it looks like we got a good amount crossed out here right now. So the only thing left in that numerator is the x plus 1. I can put parentheses around it or not because there's nothing else in front of it to warrant parentheses. But I can put them in there if I felt like it. You could if you wanted. And the bottom is just x minus 7. Same deal. And you guys, that's it. There is no other spot for you to reduce. Again, you can't be saying, hey, how about those x's? Those x's are touching addition and subtraction symbols. That's off limits. It's got to be times. So that's part 2 of the video. And looks like we're running right around the 14-15 minute mark, which I think is what the first one was. So the next time I shoot a video, it's going to be the division models. And division is not that different from multiplication. So if you can figure out this, division has one little introductory step, and then it turns into these problems, and they'll be very similar. So until next time, that's the end of this one. I'll do part 3 here shortly.